Okay, now, so you guys have you guys have seen errors in Matlab divide by, one of the common errors is matrix dimensions don't match or something like that. You can generate your own errors. This is uh, this is the error function. You can make your own messages. So if you're in a routine and somebody enters the wrong parameters into your inputs of your routine, you can generate an error. Let's see. Get down here. Okay, let's do an example of one. For example, I'm going to make a function file. I'm going to call it and it's not error function as in, they call it the error function for cumulative probability distributions. So I'm going to have like an input just x, or actually I'm going to make the input k. And I'm not going to have any outputs. So if k equal, remember you have a double equal if you're testing for something, k equal 1, then error, give it a message. It'll throw an error. They call it throwing and catching errors, by the way. K not equal. So this is just showing how to generate error messages within your program. And it didn't toss me the error. So let's go figure out what's going on. It might have been the semicolon. I thought the error function would work with the semicolon, and maybe it doesn't. Let's go find it. Display message and abort. Okay. This is your messages. There we go. Okay. This is my message that I'm making an error message. So if somebody is using, you give your routine to a buddy, and they enter the wrong, they enter a row vector instead of a column vector or something like that, you can generate an error. That's all this does. Now, make your error messages informative. If I'm, oops, let's see, put the end bracket. Oh, sometimes, by the way, you guys notice that as you're typing in, if there's something wrong, Matlab will give you a ding like this, and so you go look for what's wrong. The little dash, I don't have an opening bracket, so it tells me go put an opening bracket here. Now I've created two row vectors. If I try to multiply them together, I'll get an error. So they try to inform you what the errors that are built into Matlab. They try to give you some information of what to fix in order to make your code work right. Matrix dimensions don't agree. Okay, so then I have to do A star B prime, for example, and it works. All right. Okay, so read chapter 7. It kind of goes through the types of errors that Matlab makes and what to look for, how to debug your code. When you get an error, it's trying to give you something informative to help you figure things out. Yeah, Henry? Chapter 5 is due today. Okay. In fact, last week we actually finished talking about chapter 6, but I will entertain questions, of course. I'm just going over new material, so I'm talking a few chapters ahead, by the way. Chapter 7. This is about all I wanted to say about chapter 7. It's basically looking for the good information when you get an error. What information is it telling you? And then making your own error. Let's see, where's the editor? Yeah, creating your own errors. Yeah, if you're writing especially when things get long and complicated, you're trying to inform the user how to correct a mistake. That's what error messages are for. It's trying to correct a mistake. It also gives you a loud bang, as you'll recall. Let's see. Let's go back to. There we go. It gives a message in big red bold letters and warning, warning, danger, Will Robinson. Kind of. You guys don't watch Lost in Space anymore. You don't remember it or something. Yeah, this is kind of like danger, danger, Will Robinson. I bet we could program Matlab to say that when it throws an error message. Danger, danger, Will Robinson. Anyway, so it gives you a nice big bing, though. When you get an error, it dings you. There's your ding. So, creating your own built-in errors so that it informs people how to fix their code. And the errors already built in are trying to inform you how to fix your code. That's errors. Any questions? I wanted to get to a symbolic example today. Now, okay, let's see. I got to go to another folder. There we go. Now, the Wheatstone Bridge is a great example of a problem that is great for symbolic calculations. And this is a published file I generated on the Wheatstone Bridge problem. This is what you use to create symbolic variables. Syms, S-Y-M-S, and you can create a whole line of them. There we go. Now this is actually, we are on chapter 8. A little bit of, which that's why it's so hard for me to do chapter 4, because they go into a little bit in chapter 4. They do go through it in chapter 4, just a little. So we're going to get a little bit deeper into it now. It's in chapter 4. You can work straight through this book just fine, but you got to read the book. Okay. Add study, and you might have to go back and refer. Anything you do in MATLAB, use the help system. Okay, I don't know how to do this. I got to go back to help. I got to search the documentation for something. Use the helps that are available. Search Google, by the way. So you can't, quote, do this stuff just on your own. It does take reading the book and going back and forth. It's like physics. When you do a physics problem, you read the chapter and go do a physics problem. You say, well, how do I do, you're scratching your head. How do I do that? You go back earlier in the chapter and you see an example problem. And so you're always searching. You see something, you don't know how to do it, you go search in the book some more. Well, computer programming, and that's any program, that's not just Matlab, but any computer programming, search the documentation. If you have an idea of what's, if you have an idea of what the function is, type help sims. So on the command line, you can get some help, instant help. So you have the web, you have the help system, the built-in help system, you have the command line help, and Google. Other users may have already come across the issue and posted it on the internet. So when you're struggling with something, you got to use the helps. No book can tell you everything. I mean, I've worked through this book. It gives you sufficient information, but at times you're saying, gee, how does this work, or how does that work, or how does the other thing work? No book can tell you everything. Use Google, use help, and there's two types of helps. There's the command line help, and then there's the regular help system, the question mark.
So this, if you did like,
Use the helps. Don't try to figure it out on your own. Use the helps. Yeah, that's the message I'm trying to get across. Yes, Marty.
I don't know.
Okay. Okay, on to symbolic. We declare, so we got to declare some variables, symbolic variables. You can also do and I always forget if I have to put in these little parentheses. There we go. This is another way to create a symbolic variable right here. If I just put sim, if I did not put, well, let's do sim y. Let's just do this. If I didn't put y equal, y would not be a symbolic variable. The answer is now symbolic, but there's no y. Y does not exist in the system. So this one's kind of weird in that way. This one's a weird one. You'd have to do this. You'd have to do y equals. Now this will create a symbolic y variable. So if you're using this function to declare symbolic variables, you got to be a little bit careful about this stuff. This is the other way to do it. Okay. Let's get back to here. I'm going to make a matrix. We'll show what that matrix is in just a second. It implements Kirchhoff's voltage laws and Kirchhoff's current laws. This will be the current, the symbolic current matrices. And the voltage vector. Okay, let's see what A looks like. A times I should equal V. A, return, I, return, V, return. Okay, let's see if I have a picture of my, I can't remember if in this file I put my picture. I didn't put my picture. So I'll put the picture on the board. How many of you guys are in circuits now, by the way? Nobody? You've taken circuits? How many of you have done any kind of electronics? You understand circuits or something? Anybody? Yeah, some of you. Okay. So this is current splits up in these two resistors. It can go through the middle one. This cannot be solved with parallel and series resistors. You can't break this down. You have parallel resistance formulas. You have series resistance formulas. You got to go back to Kirchhoff's original laws to solve this. So the total voltage is I think this is how I labeled it. So the voltage is current through R1 times current through R1 times R1 plus current through I3 times R3. So the voltage here. Yeah, that's kind of thing. It's Ohm's law. Ohm's law. Voltage, the first voltage is current 1 times R1 plus current 3 times R3. The second voltage, the battery voltage again is R2 and R4. Current through R2, current 2 times R2 plus current 4 times R4. Battery voltage, you can also go R2, R5, R3. So current 2 times R2 plus current 3 times R3 plus current 5 times R5. So you're going, one time you're going this way, another time you're going this way, another time you're going S pattern, like this. And then the current at certain nodes, current 1 plus current 3, let's see. Oh, okay. Current 1 plus current 5 has to equal current 3. In other words, what's coming into this node, what's going into this node has to leave this node. Current 1 plus current 5 minus current 3 has to equal 0. Also, yeah, the current 4 plus 5 has to equal current 2. So current 2, 5, 4. So this is implementing Kirchhoff's current laws and Kirchhoff's voltage laws. You don't have to know what they are. I'm just setting up matrices. So if you don't understand this setup, don't sweat it too much. This is just matrix A times matrix I has to equal matrix V. And we want to solve for the I's. Okay, let's go back to here. Basically, some of the wording in my output, publish output file talks about this. This is how you get I. Let's see, matrix A, that's the resistance, times matrix I equals matrix V. So to invert it, you got to do this. A times I equals V. So we'll, and, right, there we go. Big and hairy, right? And we can simplify. Let's see, how big and hairy? It's really big and hairy. Take a look. You would not want to do this by hand. This is not too hard to do by hand. This, well, yeah, it's kind of hard. Simplify. Oops. So we can get it simplified. It doesn't look like it's taking the, well, it looks like there's been a little simplification. If you multiply, you get the 5 resistors. So we have a matrix of currents. Let's see. Okay. Um, so we want to get R. V equals IR, Ohm's law. So we take the R vector, R1, R2, R3, R4, R5, and I think did I define that already? Looks like I didn't. Okay. It's going to automatically be defined when I execute the statement. So V over I, and you have the battery voltage divided by these currents will give you the resistances. Let's see. So we get a bunch of R matrices. We try to reduce this a little bit, simplify it. It doesn't look like it's taking much simplification. The um, the total current equals, now this is a row vector now. The total current is I1 plus I2. The trick is to get the effective resistance of this circuit. You just take the battery voltage over the total current. That'll give you the effective resistance of the circuit. And I'm double checking my work from before. I've set up a current vector right here, which I'll go ahead and execute. There we go. So I ought to have, there we go, a 5x1 symbolic matrix there. Effective resistance, EFF, not 3FF. Effective resistance is battery voltage divided by the total current, and let's see. I'm running into, you'll notice it's leaving it in terms of IT. Let's see. Okay, we get all these different R's and things like that. Now, working with symbolic. Okay, you're starting to see some of the problems working with symbolics. Is that, darn it, I want this in terms of resistances. I mean, I want a bunch of resistances. I don't want I1s and I2s. I need to expand I1 and I2. So when we're working with symbolics, you got to play around just a little bit. I'm going to try to change this. Oops. Since I1 and this and this are in terms of the VBs and Rs and all that kind of thing, let's see what happens here. Oops. What doesn't it like? Boy, it didn't like that. Something weird happened, okay? It cut and paste. Now, okay, now I've got an expression. I can start simplifying it. Oops. And let's pull this back a bit. So we get a big fat denominator. I think this is as simple as it gets. Okay. This is a very difficult problem. It would be almost impossible to do with by hand. Um, it is possible if you're very careful. You have to go through a lot of stuff. Not too bad with Matlab. The um, and now you can evaluate. Now you have a formula in terms of all the individual resistors of the effective resistance of this circuit. So so now you have a formula. You can go from there. You can build. You can cut and paste this into a function, for example, um, or substitute values and the like to keep going. Okay, so that's an introduction to symbolic. Are there? Is there? Can you? You mentioned chapter 4, a problem in chapter 4 with symbolics. Is that correct? Did we ever have to do anything with symbolic so far? Where? What problem? Do you recall? Second problem. You had to use symbolic. Did you use the single apostrophes? Okay, I don't see anything where you need. Yeah, I don't see anything where you need symbolic calculations in problem 2. Yeah. Yeah, you do not have to use symbolic for that problem. Okay. Yeah. Okay. Main thing about symbolics. So we got 2 symbolic variables. Um, oops. There we go. Oh. Now, when you do this, ladies and gentlemen, you declare X symbolic, and you do this, um, all of a sudden it turns into a non-symbolic. It takes it away. So in trying to evaluate symbolics, you have to um, you have to use the formula. You can't just set X equals um, X equals something, and then the variable X goes away. I've set it equal to 2. It's 2 divided by Y. Now if I wanted to do if I want to do this, if I want to change Y, it will not change Z. Oops, it will change Z. Or no, excuse me. Yeah, it. Yeah, of course. Y is set equal to a number, so it evaluates it as if it evaluates the numbers. Okay. Let me do that over again. Trying to do something. I was trying to show something different here. Let's delete Z. Okay. Oops. I went the wrong order a little bit. So now I'm going to set y equals 3, but it will not change z. If I just type z, it's still this. Okay, that's what I wanted to show. Okay, that's it for today. We'll pick up a little bit next time. We are kind of past, um, we're ahead. Lecture-wise, we're ahead. So I'll plan on future sessions being more like help sessions for a while anyway. Okay.